Welcome back to the TestLab. I'm your host, Dr. Watt. Today, launching a brand new segment called Light Conversations. So what's this all about then? While testing lights is all well and good, indeed the new season of tests is well underway, we also wanted a more regular discussion-based format that allowed growers in on the conversation in order to cover some of the issues raised by the data TestLab generates in relation to genetics. We also want to cover light news about the latest trends and developments. It's an idea that grew from our regular TestLab production meetings, and one day we realised that we already had our talk show. We just needed to record it. It's actually a very simple formula. 4 guests in one car with one microphone having a light conversation. It worked so well that we didn't stop blabbing for almost an hour, so we broke this first episode up into 2 parts, and this is part 1. Hi there, Monster Gardeners. Welcome to the first episode of Light Conversation. I have with me Ryan, who you know from the videos, Steve, who you also know from the videos, who's now moved on to Cultivation Suppliers, the commercial operation of Monster Gardens, and Dylan, who, if you're anywhere near Monster Gardens location, you'll know from our store. Hi gents, how you doing today?
Hey, pretty good. Ready for an exciting conversation.
Having a great old night.
Let's light this one up. So what are we talking about, boys? The hot topics these days seem to be a lot on supplementing spectrum, whether it be supplementing the sun, supplementing HPS. People are trying to broaden their spectrum. They realize that it's not necessarily about quantity, but it's about the fine balance of quality and quantity. Honestly, it seems like nowadays more people are trying to do methods of recreating the wheel rather than just following what the leaders in agriculture are doing. I find it quite funny sometimes when people supplement a full spectrum sun with a full spectrum light. And so we're here to kind of set some of these theories straight.
There's an interesting aspect to the controlled environment agriculture industry, whether greenhouse or warehouse. The warehouse being no lighting source unless you're using solar tubes, which isn't very typical. But what's typical is to try to recreate the sun's light indoors. And we've seen over the years a nice generation of different technologies that have been trying to achieve that. Really starting at the CMH, the ceramic metal halide, which now has also been called the LEC, the light emitting ceramic. Same product, just different packages. And what we've seen there is the CMH, which is really designed for color rendering, for true light, so that when you're buying something, you can see those true colors. You know, we've said this in past videos. You know, the CMH light has been made to mimic the sun's lighting spectrum for indoor use when you're going to buy something, you want to see the color of it. But growers noticed it also had some great attributes, being close to the sun spectrum, to be applicable to growing indoors. And so what we saw was a nice indoor light, which was the ceramic metal halide. And then we saw it go away. It was a fad almost that was in the mid-90s. We saw it kind of pick up a few times, and it was almost an interesting situation to see it be re-released under the LEC.
Well, it was funny. I remember, years ago. It was almost 5 years ago, pulling the Philips ceramic metal halide off the shelf. The last one that we had, it had been discontinued, and we pulled it up and we talked about the product and why it went away and possibly reinvigorating it and trying to find a lighting engineer to engineer a fixture around that, but to essentially beef up the wattage on the output to make it more applicable for mother plants. Greenhouse lighting, essentially, anything. I mean, more than what we were seeing at that time, which was fixed at the 250 watt to 315 watt level.
You're right. It was very limiting, and we also noticed at the same time that there was an interest in taking two of those lamps and putting them together to create more output that would be more consistent to a 600 watt or 1000 watt HPS or metal halide. And we did do a past video at Monster Gardens that you could watch, which compares ceramic metal halides, as you want to call them, to metal halides.
Yeah, standard metal halide.
And even the new DE metal halides, which is something we should move into.
I'm even seeing DE CMHs now. I'm seeing them advertised quite a bit. We actually have Dylan, the assistant store manager here. Are you getting any kind of feedback on those dual CMH lamps?
You know, for the most part, all I'm really getting is questions. I'm not really getting any answers out of it because 9 times out of 10, the customers that I deal with have never seen it in person. They've never used it in their own grow, and all they're hearing is hearsay that they read on the forums. The main problem that I've seen with recreating a metal halide is the fact that you have to make sure to house the actual arc tube in such a way to where if it were ever to fracture or explode, it would still have a little bit of room to where it wouldn't be dangerous in your garden. Yeah,
that's why we're seeing the double jacketing.
Exactly. Yep. And
I mean, part of the problem with this is, and this is just for all the research that I did for the test lab, is both DEMH and DECMH. The technology was designed for HPS. The size, the spec, everything was designed around that HPS arc tube.
You mean the double-ended housing itself?
Yes, exactly. And so all the dimensions, the materials, the fact they use quartz instead of borosilicate glass, it's all around HPS.
And then somebody thought it was brilliant to take that existing jacket and throw another arc tube in it, and voila.
But it's funny how the inventor of DEHPS didn't do that. You know, Philips just got the hell out, and then Philips invented CMH.
Mm-hmm.
And then they got out of that as well, and now everyone's going mad. I mean, here's an interesting question from, someone that's still new but technical. I mean, is this side of the business regulated at all?
It's really an interesting subject because when we're taking lighting systems and re-engineering them, they do need to go through an approval process, ETL, UL, and let's just admit that not everything that we see in this industry on the lighting side always falls into that realm on its initial stages of moving into the market. Sometimes it ends up being that they introduce the product to the market, see if there's interest, and then they move through the process of trying to gain, certifications. And I really feel that it's hard for the consumer to be able to know if products that are new, that are by companies that are small. I'm not saying Philips, but maybe the smaller industry company that's not nearly the size of Philips, or even a company the size of Portalux Schrader, PL, but is putting in these new lighting concepts, and they're using it as almost a proof of concept in a way by introducing these into market. And it's why we see a lot of these new arc tube systems come into the market and come off. We did see a 900 watt CMH a couple years ago.
Quickly yanked off the market.
I forgot about
and so,
My word.
And so it's really, the consumer needs to not maybe jump on these systems on changing out and swapping out their fixtures for new ones. When they see something arise in the market, there's nothing wrong with just getting one and trying it out. Part of the reason why we provide these video references is we're trying to take all the experience that we get, not only from our client base, but us as growers ourselves and our own network of growers, especially with Steve here from Cultivation Suppliers. You have customers with 90,000 square foot gardens. So we really try to take the perspective of all of our different clients, all of our different folks that we have in our network, and we try to take all of that experience, all that relative working knowledge, and try to produce it in these video formats so people understand what's being seen. But even on the commercial side, there's nothing wrong with having just one fixture and just trying it out. And when you try it out, you probably don't want crossover lighting from another fixture. You want to do it as much of a controlled test as possible. But there's really interesting things to know, and that's that there's a lot of secondary responses the plant gets from this more broad spectrum, let's call it, lighting. And some of those, benefits that you get from that broad spectrum lighting, sometimes you see them only when your plant stresses and you want to rebound that stress. Sometimes you see it for, as a benefit when you go through the flowering cycle and you're trying to get certain essential oil production and you start noticing that benefit. Maybe, you have a variety that is susceptible to certain things and you want to create a lighting spectrum to limit that susceptibility. But there's a really interesting science that is just now getting underway with photobiology and plant response. And I really feel that we're going to start noticing this broad spectrum as being a benefit over more narrowed spectrum lighting fixtures such as metal halide or HPS or even red-blue LEDs. Because red-blue LEDs, though they're achieving a great efficiency, the secondary responses of having a more broad spectrum light has shown to be beneficial in a lot of placements. But that's an interesting one that you brought up, Steve, because you brought up broad spectrum lighting used in greenhouses.
I just seem to come across it all the time. It seems like greenhouse is taking up a huge amount of the commercial interest these days, and primarily on the West Coast. And it's just odd. I just can't fully wrap my head around it. And I'm the kind of guy that does research, and I don't officially write things off unless I physically can test it or I can have research backing it. And this one is just kind of has me dumbfounded because, one, the broad spectrum opportunities that people are going to be using are generally lower in the wattage. There are some commercial ceramic metal halide fixtures coming on the market that will not shadow the light, but they still don't have the throw and the depth penetration into the canopy, so it just fully doesn't make sense in that aspect. And also the fact that the times that you're going to be turning your lights on are, generally speaking, times of the year when the light levels are low or when you have cloud cover. And when you have cloud cover, you're actually decreasing the amount of par light toward the upper end of the spectrum, more of the orange-red portion of the spectrum. And so it naturally makes sense to supplement with a high-pressure sodium lamp. And not to mention, when people are using these supplemental lights in greenhouse production, they're usually growing higher plants. They're growing fruiting or flowering plants. So that also favors more of an HPS-like spectrum, which is why companies such as Hortilux Schrader, when they literally wrote the book on horticultural spec lights, it was primarily an HPS spectra. That's primarily what they used really for years and years until they soon came out with the metal halide option for more vegetative growth or for standalone light, not in a greenhouse. Now we're starting to see the double-ended lights, but still, they're primarily from greenhouse. That's why they're HPS.
I agree with you. I thought it was really funny that we see these low wattage fixtures in greenhouses and they're 12 feet off the plants or 10 feet off the plants, and the sun's there. The sun has more spectra than you're going to get out of any LED or HID type of product on the market. And then you're putting a low wattage full spectrum fixture in there to supplement on those days, where I would want something that holds more photonic weight like an HPS, because you already have full spectrum, and now I'm getting additional spectra in performance characteristics that are a little different. And we've known since, farmers have known since the 50s and 60s that red spectrum swells flowers. And so we know that if your goal is not only a great quality crop, but a quantity crop, because it's typically what growers are paid for. In greenhouses, that we still see HPS as a great benefit. And there are LED fixtures that also would fit in really well, but it really depends also where your greenhouse is located. If your greenhouse is in Monterey County, California, you have the most mild climate in the country. You don't maybe have the most amazing cloud cover days, but you do have some. And, in that area, we're going to see the availability to have lighting fixtures that you might not see in other areas. We're in Washington, and I'm actually using my lights to partly heat my house. And, now I'm looking at the spectra difference that I'm getting in Washington with my cloud cover over standard, sunny days. And maybe now I'm looking at more of an HPS fixture because I'm trying to hold more photonic weight. I'm trying to have a warmer fixture in my overall greenhouse to warm it. But it is important to know that depending on where your region is located, you might be using your lighting for other things other than just lighting. And at that point, you might want a lighting fixture that does produce heat, because the days that you're going to be utilizing are going to be days that are typically cold. where, in California here, we don't have such, significant temperature swings. We might have a cloudy day, we don't have a huge temperature swing, and you're just using the light to change that photometric period.
Right. Well, that's what I was going to say. I mean, yeah, it boils down to your vision. Do you just need to extend the photo period and keep your plants in veg?
Mm-hmm.
Or are you actually trying to maintain a target light level throughout the course of the year?
Yeah.
And that boils down to light density and your light choice.
Mm-hmm.
And up until this point, I would say that HPS takes the cake. Primarily double-ended HPS because of efficiency, slightly higher output, more of a broad spectrum. Because keep in mind, I mean, I know you know this, Ryan and Dylan, but you viewers at home, well, especially you too, Dr. Watt, I know you know this, but the arc tube in the double-ended lamp actually is enhanced. They actually throw a pretty decent amount of blue spectrum into that arc tube. And the theory behind this is so you can use it all season long. You don't need to swap lamps. These manufacturers were well aware of this, which is why they never launched a double-ended metal halide arc tube. But even beside that point, greenhouse manufacturers, greenhouse growers, they all know that the actual glazing of a greenhouse will filter out much of the ultraviolet radiation that comes from the sun. And so the idea behind it is to supplement with additional blue spectrum so your crop is still able to receive that portion of the spectral output. And so in addition to giving you this enhanced ultimate HPS spectrum, we're also supplementing with the portion of the spectrum that's been filtered out from the actual greenhouse glazing. And that's why you'll see your glazing begin to yellow over time. It's really just because that spectrum is degrading that actual polycarbonate or polyethylene, whatever glazing you're choosing to use.
Well, it's pretty, you bring up a good point there, because if you're just lighting your greenhouse to adjust the photo period, we're going to try to do that with low intensity lights.
Yeah.
And, now we're looking at lights, fixtures that are at 200, 300 watt
Right,
level.
that's when I'm looking at LEDs.
Mhm.
I mean,
and you're getting great efficiency there. They're very high up. LEDs typically today don't have a lot of depth penetration in comparison to an HID. So you can if you get an LED that's made particularly for a greenhouse, which you should, you're going to find one that is a long bar, fits within the channel of the greenhouse. When you're looking at a fixture for a greenhouse, you're never going to put a large fluorescent fixture in a greenhouse. It's going to shade your crop. Your sunlight is obviously not only free, but it's superior to any lighting you're going to put into the greenhouse. So it's really important for you to look at, your fixture and see, was that developed to not have a shadow, and that's important. But in the LED world, when you look at those kinds of fixtures, because of the way the diode configuration is, you typically have an LED that's made for stacking, is made for vertical gardens. When you find a channel LED that's very long and doesn't have shading, that's typically what you're going to see in those production characteristics.
that's exactly right.
So there are LEDs out there that don't fall into that characteristic. There are compact LED fixtures that don't fall into those characteristics. The only issue is because of their wattage again in a greenhouse, you would have to stack so many in comparison to a standard HPS. Now you might start seeing some shading. And so the question to the grower is, it's really, what is your production goal? Is your production goal to change the photo period because it's fluctuating so much because you have a weathered area? You have an area that gets a lot of weather. The other one could be, maybe you're in a cold region. Maybe I'm Canada. I'm having to heat my greenhouse in addition to that. And maybe you're here in Monterey, California, one of the most mild temperature climates, and you're just playing with lighting spectrum because you're trying to manipulate the plant into having different compound production. And now we start to get into some really interesting topics.
First thing you do with any lighting setup is ask yourself what the end goal is.
But that means you need a developed business strategy.
Right.
And if you have a developed business strategy that you're going to stick with for a long period of time, which means you've probably developed that strategy off of some experience to begin with, that's where you really get the ability to find the right pairing product. Because the question is the product right? Well, let's say that half the products in the lighting market seem to be quality. But out of that half, and we're not centering on one technology or not, and that's just commercially viable brands. Out of that half, we definitely see that there's a specific application for that fixture. There's a design philosophy for that fixture, and that really goes into the LED world. So since we're talking about LEDs and we're kind of moving from different lighting topics, with LEDs, I really see that the design philosophy ends up being the footprint of the fixture, the distance, which affects the footprint, but the distance off the canopy, and its commercial viability overall. And so the design philosophy of the fixture could be a high quality LED fixture, which is really what we're looking for. So we just assume if we're talking about LEDs, we're talking about commercially viable LEDs. We're not talking about fly-by-night LED companies.
Right.
But
real lighting manufacturers.
Real lighting manufacturers. But when we get in there, then we talk about design philosophy. LEDs have completely different design philosophies from one manufacturer to the next. A lot are starting to now try to target HIDs, so they're going with compact fixtures for depth penetration. But footprint and distance is very important because out of the LED fixtures that Monster Gardens carries or has access to, their footprints are, and you know this, Dr. Watt, are significantly different between the different companies.
It's one of the primary reasons we haven't had any tests yet. Is how do you build a test? A standardized test for such a wide range of footprints. I mean, there's almost no two the same.
Yeah.
And they're so application specific. It's almost like we have to build a test tent for every single light.
I mean, it's almost easy to say that there's so many characteristics in LED, from spectrum to its design philosophy to the configuration to the actual components that went into it, that you could almost say that each LED is almost a fingerprint of the manufacturer, and they're very different from each other. Because they all have their own design philosophy that they start with.
It's all starting, it starts and finishes with that, because LEDs are so flexible because they're so small and so low drop. Literally, you could coat walls with them if you really wanted to. I mean, that's eventually going to be the
that's like
holy
the same.
grail
That's the
LED
idea.
is luminescent paint that you just paint on the walls.
Let's talk about that. So that's really important because Samsung has a low wattage LED where they put many in the fixture, and then we see other companies that are very consistent in the industry, which we see, which is going to be Cree or Osram, where they're pushing out really high intensity LED chips, which are really going along the philosophy of less fixtures in a room, compact, more comparable to an HID replacement, where you're talking about a lot of that stuff that we're going to see in compact high density farming, where those fixtures are very close to the plant. But then what is your plant type? You're not growing a plant that's growing very fast. So you're growing basil, you're growing low leafy crops. Again, the compact fixtures for high intensity growing are typically going to be for large crops that are 4 or 5 feet when you take them down, maybe even vine crops. So that's important to know. But in the LED world, the fingerprint is not just the footprint. The fingerprint is not just the commercial viability. The fingerprint's also the spectrum, because that's one of the things that these guys get to play with. We look at HIDs, we got PL, we got Gavita, we've got Phantom, we've got all these different DE manufacturers we could name, and they're all using somebody else's bulb or their own, but they're so darn close to each other.
Yeah, I mean, you could arguably say they come from only a handful of factories.
Only a handful of factories. And the same things with the CMH LEC. Again, very consistent, handful of factories. Now what we're talking about is commercial viability and what is the reflector. That's it.
Right.
They're not very complex, but in the LED world, now we have to talk about the design philosophy being, what did they think that light spectrum would do to that crop? And that's what they built off of for their light spectrum piece, which is really interesting because LEDs are the first lighting product that for us are hard to quantify against each other. We use metrics like UMOL per watt, micromole per watt, because that tells us its efficiency for how much light that the plant can pick up, for how much light is being used. But that's also, you got to take in consideration the spectrum, because you might have a UMOL per watt metric that's fantastic, but when you are looking at a red-blue LED that has maybe a little bit of white, and then you look at a full spectrum LED and you take your UMOL per watt, we're not talking about the same product at all. We're talking about two products and we're talking about their efficiency, but we're not talking about what they're going to do into the plant.
Exactly.
And that is a really big aspect that we're going to see in photobiology that's going to be significantly changing over time. Whether it's a Lumitex, whether it's even the new PL Horty LED that's coming out, or the 100 of other LEDs out there, the Spectrum Kit, we can name a bunch of them. They all have a different philosophy overall on their spectrum. And growers are going to see not only from plant varieties, but even phenotypes within those varieties. They might see some favorable characteristics of compound production from a slightly different spectrum versus another. In our folks at LumaGrow that we've been supporting the LED world for a long time, they've actually seen a lot of that research. They've seen people dialing the spectrum manipulation with the same crop type, but different phenotypes within that crop, and they actually see different compound characteristics. That's interesting.
They have seen some pretty phenomenal research, and it's gonna get really fun. I mean, basically, the cannabis industry is unique because there's so much red tape, and it seems to be breaking down that red tape every day that goes by. And companies such as LumaGrow that has the research that they've been trying to do for years and years, and they have their clientele producing quite a bit of research.
We are now seeing the renaissance, as we call, of photobiology in plants. And we are about to go into this world where controlled environment agriculture is this new focus because of this new crop that is being newly accepted, that it's creating a lot of financial opportunity and a lot of research and investment. And it's finally a cool time for us to see an amazing advancement in this realm. You know, people have tried to even allow you the ability to do some of that testing yourself by using programmable spectrum LEDs. And Illumitex did a really cool play on that originally with the triphosphorus chip, where you could actually adjust the spectrum, red and the blue, but actually changing a programmed spectrum, a specific wavelength in the chip. Now, programmable spectrum chips have been available through a number of companies now. They have different ways of accomplishing it, but what we've noticed through our testing is they've never been the high performance LEDs. They never had the high efficiency. Helix Spectrum was another one that we tested too. These fixtures they didn't have the weight per LED chip and that high efficiency, though they had cool spectrum manipulation capabilities. But what we do intend is a lot of research to start coming out and surfacing where people can see the research that others are doing, using diodes that they're buying off the shelf at specific custom spectrums and finding out what that does to the plant.
The thing I noticed that's pretty funny is a lot of the manufacturers, the LED manufacturers, are actually really overdriving their diodes. They're completely overdriving them, and that's why you're seeing these amazing heat sinks, or they're separating and actually giving them a remote ballast.
Mm-hmm.
We're going back to remote ballast again because they literally just can't keep the driver cool.
And that, dear viewers, is where we must leave it for this first episode. We really hope you enjoyed the new format, as we all think it's a worthy addition to the TestLab. I'm off now to put the finishing touches to the second edition so I can have it up as soon as possible. But until then, mind how you grow, my friends.